Welcome back to my budget app series, where I attempt to build a personal budgeting web application from scratch and document the process on YouTube. This is video number 3 in the series, and today we're going to start working on the actual server application. The work will start by building the models. Let's jump into the code and talk a little bit about architectural changes since video number 1. Alright, to start, I have the entity relationship diagram, or the entity diagram because I haven't denoted the relationships between the entities. This diagram was created in video number 1 when I designed the overall architecture of the application. I turned a lot of attention to the entities of the application, the database entities, that is. And that is important in this video because we'll be building the models by this diagram with these fields and the appropriate data types and relationships. With that in mind, since the first video was published, if you haven't watched that, I encourage you to do so before this video because the architecture is fundamental to what models we'll be building today. Either way, since then, I decided to make a change to this to the entities because I think I can normalize the database further, and I'll explain exactly the change I'll make. So I have 4 entities, and this is an enum type that is denoted like an entity in this diagram, but we can ignore it for now. So we have the users entity, again, that has an email, password, first, last name, and currency preference, just basic fields. We can ignore that for now. The user entity is clear. I want to make changes in these, the primary entities of the applications, where we denote the transactions, the transaction categories in the actual monthly budgets. So how our app works by this design is that a user has categories. These are created by himself. These can be categories of type, income, expense, savings, or debt. And they're basically user-defined categories. If I open the design, I think I can clearly show you the categories entity in the user interface so that you can have more clarity. This is the design I worked on video number 2 that I'm using for reference. So a category in these income, expenses, debt, and savings would be these user-created categories. For example, in expenses, in the design we have housing, utilities, groceries, etc. These categories have 2 special properties. First of all, you can plan an amount for the current period, which is a month, which you would spend for each of these categories. They can be related to transactions that happen so that you can see the actual paid amount based on the transactions you made during the month. And lastly, if the categories are a debt or a savings category, they have an accumulated amount or a leftover amount when it comes to debt. So this is an amount that is independent of budget periods and accumulates or is taken out of, depending if that is a debt or savings. So to achieve that basic functionality, I have transactions. These are individual recordings of just financial transactions that are recorded, basically money going out or in from the budget. And transactions right now, they have a date and amount. They are related to a budget. And a budget in this design is something that has a category. So first of all, let's see, the category has a type of income, expense, savings, or debt, title, accumulated amount, and is related to a user. So the category is how we relate the budget to the user, but the budget item has a category, an amount that is planned for the period, and the month to which it relates. So the budget is the primary category that binds the category to time, to the actual budget period. To explain it a little bit clearer, I hope, this housing category that the user created would be in this table. You would have a housing budget, in this case for January 2024. You would also maybe have a housing budget for February, March, April, etc. So the budget currently is housing for a period. So housing for January would be one budget item. The problem with that design is that there's a little bit of repetition and data retrieval is a little bit hard. So let me explain. If I want to retrieve the budget for January 2024, I mean the overall budget, this view basically, I have to retrieve all budgets from the database that have a month set to January 2024. That's not particularly crazy as an idea, but the actual budget I create right here for January is not an entity in the database. The other thing is that the month field is repeated multiple times for each category. So to solve this kind of normalization issue, I would call it, I decided to separate budget as an actual budget that is close to the physical idea of budget being the planning, the overall planning for a certain period. That would be the budget for January 2024 would be all of these categories and their planned amounts so that I can retrieve them from a single database record. Of course, they will be related items to that record. There will still be a record representing that budget. And I think budget, in terms of how it's called, the entity, is more intuitive if it works that way. And to achieve that, I need to create a different entity to bind the planned amount for each category. And I would call that category budget. That's what I decided to do. It would still have a category ID, that would be a foreign key, the planned amount, but instead of a month, it will be related to an actual budget. I'll actually move amount last and I want the budget ID right here. So this category budget will be related to the budget, which now will not be for a single category, would not have an overall amount. It will just be an item with that is bound by a month. It's just a period that is related to category budgets. And lastly, the transactions will now not be related to a budget. They will be related to a budget category. And that's the change I'm going to make. This way, month wouldn't be a repeated field. Data retrieval would not involve retrieving the categories for each budget. I will retrieve all the category budgets, but they will be related to a single budget record. For example, January 2024. The month field will be unique in the sense that you would have only one budget for a certain month. And that is a primary change. The only other primary change I'm making before we jump into the creation of the server application is related to the database choice. I was planning to use Mongo primarily to experiment with a NoSQL database and with Mongo in general. The problem is I want to use an object relational mapping library that is stable and proven and supports TypeScript, and it allows me to write dry, maintainable code that I like. With that in mind, there are options for Mongo. You can use Mongoose. Of course, that's probably the most frequently used Mongoose ORM. The problem here is its TypeScript usage. I don't like particularly. I'll show you what I don't like in this TypeScript usage. Let me zoom in. This is a typical Mongoose TypeScript model. You have to define an interface, of course, with the types for each field. Then you have to define a schema with the same types for each field. And then you create the model. Of course, that's not extremely annoying, but keep in mind you have multiple models, and this duplication of type definitions can only lead to errors. In addition, I would like to be able to generate an API or a GraphQL query from these same types, if possible. And if I want to use GraphQL, for example, which I haven't finalized as a decision, and I go this route with Mongoose and MongoDB, I would have to define the interface, the schema, and then the GraphQL schema, which I hate as an idea. That's terrible. You have to maintain the same types, the same data, essentially the same schema 3 times. That's just an idea for errors. You would, at this point, the maintenance of your application would be just keeping manually in sync lists of properties and their types. Of course, there's a solution to that. There is a solution to that. TypeGoose is essentially a library that allows you to define Mongoose models with TypeScript classes. It solves pretty much all of these issues, and I like it. It solves them by using decorators in a TypeScript class. You define one class and then you decorate it with decorators to basically generate the schema. That's great. I love that. What turned me away a little bit is that if you go with Postgres as an alternative to Mongo, you have TypeORM, which essentially has very similar features in terms of syntax, with the only difference being that it seems to be a more popular library that hopefully would be maintained better. It definitely seems a lot more mature in terms of both development stages, documentation, and I think features as well. TypeGoose is a little bit, it seems new. I don't know the exact date when when its development started, but the project seems to have switched hands recently. I don't know if I wouldn't at all say that it's not maintained, but the numbers of contributors just don't seem to be a lot. It doesn't seem like a very mature project. In terms of features, it has most of what I want, but I was also kind of really struggling to decide between Mongo and Postgres and a relational database versus a NoSQL database. And that kind of turned the tables for me, that the ORM library in TypeORM seems to be a little bit more mature and better maintained. And I think I have more trust in that open source project for the foreseeable future. So yes, I decided to change the database because of the ORM. Of course, by now you should have figured I want to use TypeScript for my server and my client. That should help me avoid unnecessary errors, make the code base a little bit more maintainable. The cost is very little, primarily in terms of setup, a little bit in terms of boilerplate code you have to write, but that's very, very worth it, in my opinion, especially if you're building something more serious, like a project that you want people to use in production and you need to maintain. So, with that in mind, we need to set up a project. And I'll start with a folder. The overall architecture of the application would be a monolith server. I have decided that because the entities are only a few. I've already mentioned that. So a monolith server with all of these entities and a REST or GraphQL endpoints to basically retrieve that information. So at this stage, I have to create that monolith server. And we'll need the Postgres database. When the application is finished, the database, the server, the client will all basically be deployed as Docker containers. So at this stage, what I'll do, I think, is the most appropriate. What's the most appropriate way to set up a database at this stage is to basically use Docker Compose in the server to set up the database so that I can work on the server, and then gradually that Docker Compose will move into its own repo where it will actually run the server, the client, and the database. But at this stage, I will run the database as a Docker container with Docker Compose in the server repository. while we develop. So to do that, I'll create a directory. I'll call it BW server for budget warden, which was the marketing name of the application. That's not that important. I would usually use the server service word for these backend services that are RESTful APIs or just, RESTful APIs, any kind of server. All right, to start, I opened the directory with VS Code. I'll zoom a bit. First steps, I will create an npm project, very basic, index TypeScript. Yeah, leave the default license for now. I just need the basics for now. All right, next up, I'll create a source directory and an index TypeScript file inside of it. This will be the application entry point. Let's install some dependencies. I'll start with developer dependencies. Actually, I need TypeScript. I will need tsnode. To run, tsnode is used to just run TypeScript files with one step without compiling them. It does compile them in the background, of course. Nodeman for development, and we'll need types node for the Node.js types. And is that it? Yeah, let's install this for the beginning, and we'll create a few scripts to build, start. So I'll start with the build command. It will just run the TypeScript compiler. That's tsc. The next up, the start command will build in this directory. So the start command, I want to run the compiled index.js file. So that would be dist index, basically. This won't be used frequently. What we'll use is def. That will run nodeman, and it will execute tsnode source index TypeScript. So this will watch and run index TypeScript with Node.js. So let's just test that real quick. If it works correctly, I'll first build. Of course, I won't build. I don't have a TypeScript config. But let's run the tsnode command with def. I can make changes, all of that. Great. Okay, next step, we basically just set up TypeScript, a TypeScript development environment with Node. Well, not completely because I need the TypeScript config, but I'm leaving that for later when we set up TypeORM. Now I want to set up the database. And to do that, I'll create a docker compose.yml file, which, as I mentioned, will not live in this repository. It's just temporary until we have an actual server client combo ready to create a separate repository for that deployment. Basically deployment procedure. Now I'll close some things, type goose, type ORM. I will open the Docker Hub to look for a Postgres image. That's where I'll start. We need the PostgreSQL database, and this is the official image. I always, when you are looking for Docker images for production projects, especially, try to stick with official images or at least verified publishers. Investigate who maintains the Docker image in question, because that's important. You need frequent updates related to security, stuff like that. And this is the official Postgres Docker image that's maintained by the community, but as it is a Docker official image with so many downloads and maintainers, it will be updated frequently for sure. Now here in the overview, you usually have information how to run this image with just the Docker CLI, with Docker Compose. If I look for Compose, yes, here it is, which we will need. And you also have information about the environment variables you need, the ports that you need to export, everything necessary. I rarely have to go outside of this overview tab when I'm spinning up some dependency with Docker for my development projects, which is great. I really like Docker for that, especially Docker Hub. That I guess that's a praise for Docker Hub actually. So let's copy this Docker Compose example and we'll edit it. Version 3.9 is the version of the file, and services, I'll call it database. This is basically an arbitrary name you choose for your database. Let me collapse that a bit. All right, Postgres is the image. This will pull the latest. Restart always, pretty self-explanatory. I'll remove the memory limit. Especially during development, we might consider these options during deployment. The same goes for volumes. We'll consider this during deployment. We have an environment variable, Postgres password, which right now I'll set to Postgres right here. When we deploy, we will deploy this with an environment variable. And of course, it will be generated from a secret. It will be a safe password. Here's another service. This is just an example, so I'll remove that. The defaults for this for the username, for the ports is what we'll use. I just need to see what they are. No ports are exposed here, and I need to. Let me check what the port was. It should be mentioned here somewhere. Okay. Okay, it isn't. Let me see. PostgreSQL default port 5432 is the default port. So I need to expose that so that I can access it from my application that is currently not a service in this Docker, not a Docker container in this services cluster, to say. All right. Besides that, the default username is Postgres. And yeah, we'll create a new database. So this is enough to start a PostgreSQL database. Now in my project, if I say Docker Compose up, that will start my database, I think. Let me see. Port is already allocated. Let me just check my other projects and stop any Docker Compose services that might be currently running. All right, instead of stopping the other service that I have running on port 5432, I decided to just change the port to 5433. So what this will do is this port's declaration will map port 5433 exposed to my local machine, in this case for development, to port 5432 in the container. That is some kind of Linux OS running Postgres. So my database will be reachable at 5433 during development. And now if I run Docker Compose up, it should spin up yes. Okay. Database system is ready to accept connections. Of course, I want to run it as a daemon while I develop. So I can /d. And now the database started. I can check with Docker Compose PS that it is running BW Server Database 1 Postgres 5433 5432. All right. So let's test the database connectivity. I have dbeaver installed. It's one of the most popular free database graphical user interfaces. It works with most relational database connections. So I will create a new Postgres connection here to localhost 5433 with username Postgres and the same password, which is what we've set up in the Docker config. To just attempt to open a connection to that server, and it seems to be working correctly. All right, databases, we have Postgres, which is the default database that is created. All right, so our database is currently running and accessible. That's great. That's how we'll run it during these early stages of development of the server. Now, the next step is to set up TypeORM. And to do that, I will go to the documentation, of course. I'll just open the site and go to the Getting Started guide for the installation instructions. Now here, they start with an explanation on how to define entities and not installation, which I don't like, but the installation follows shortly. So to use it, we have to install TypeORM and reflect metadata. Let me do that. Yeah, these are not developer dependencies. TypeORM, reflect metadata. Let me copy it to avoid typos. Types node I already have. And I need a database driver for Postgres, that's PG. What else? Other database drivers. They actually do have MongoDB experimental support, but the word experimental turns me away from using Mongo at this point with TypeORM. And the other thing we need to change is the TypeScript config. But these are the dependencies we need, so I'll start installing them. And let's do the TypeScript config, tsconfig JSON file. I will open the TypeScript documentation and copy a simple config file from here. All right, and modify that while the dependencies are installing. I remove the files array. I don't want to strictly define files. I wanted to find all TypeScript files in my project, and the compiler options are okay as defaults. We're using CommonJS, of course, no implicit any, remove comments. These are just settings for strictness and compilation. Now to these, according to the TypeORM documentation, we need to do additionally these two that are for emit decorator metadata and experimental decorators, so that we can use the experimental decorators feature. Save that for now. Here it says you may also need to enable ES6 in the lib section. So let's do that. This I think has to happen here. All right. I believe it was an array. All right. And here I believe there was a target, which I can set to ES6. All right. Great. This newer target will help as the compilation will not have to go to a target that's too old. So it's less likely to get weird errors because of that. All right. Now here we have a recommendation to also use a quick start, which I would also actually do. Now this will create an entirely new project, which is cool. It's fine as long as I will do it in a separate folder and just open the files and copy whatever I need from the quick start to make things faster. These are just config files, primarily for database connectivity. So I'll go to my repos folder, to my dev drive actually, and I will initiate this TypeORM project. I will call it test, just TypeORM boilerplate. Database Postgres. Okay. And I will wait for it to initialize a new project, which actually will happen very quickly, I believe. All right, that's done. I will now add this as a folder to my workplace. All right, to see how it set up the boilerplate. I prefer this to just starting with the boilerplate because I want to have strict control over what goes here. Here you see we have like 4 spaces config, just different things that would take time to bring to configure with my preferences. This reminds me right here, I want an aldir in my tsconfig, and that should be dist. All right. Otherwise, they also have an ES5 lib. I'll add that. What else? No, I don't need that probably because my target is ES6. It should be fine like this. I'll change this to lowercase because it annoys me. The difference between the two annoys me. I think both work. Besides that, the tsconfig is fine. In terms of packages, we have everything needed. Of these dependencies we already installed. Let's look at the source. All right. I will copy that index for now and modify it. It just connects to the database and creates a new user. A good starting point. This data source TypeScript file is where the database connectivity happens. So I will copy that as well. I have to change some formatting options. For example, the quotes, the spaces. I want to add my semicolons. All right. Also, user is currently not available. We'll add that shortly. Now, type Postgres is correct. Localhost, change the port, change the username. This should, of course, be an environment variable when we deploy. Now, for development, we'll do that. I'll call the database BW for, of course, budget warden. Synchronize true. We'll leave that for now. It's important to leave it like that for development. This will make sure that the ORM will create the actual database schema in the database. Walking to false is fine. Here, the entities are listed, the user in this case. All right. Migrations, subscribers are empty for now. I can pretty much remove them. We can add them if we need them. Now migration folder is empty. This is for migrations, and we have an entity folder, which is basically the models folder, and we have a single model here. I will copy that model file contents, but I want to call my folder models, not entities, and we will need a user model. So that's something to start off of. Let me add a semicolon, do the same formatting changes. And this is basically how you define an entity using the TypeORM syntax. Pretty cool. Just a TypeScript class with decorators. I like it a lot. Now that we have user, let me fix that. And I have the user model and I can work on that actually. Let me close the other items. The user model, yeah, it's currently a default model. Let me go back to the documentation of TypeORM. There are two types of models you can build right here. The default one, which we currently use, when you use it, you create basically an instance, you set properties, and then you use the user repository to save a new item, to find items. I would prefer what they call the active record implementation, which is close to a traditional model implementation in an ORM, something you would see in Microsoft's Entity Framework back in the day, or yeah, basically many ORMs, where we have to extend base entity. That's the only difference between this definition and this one. You extend a different class. Besides that, you extend the class. Here you don't. This is basically just a decorated class. There's an entity decorator, and here you extend base entity. And when you extend base entity, you have an active record. So you create a new user, you set its properties, and then you can save that user. You can use the class itself and its static methods to find one. This is very nice, familiar. I prefer it to this repository model personally, although this has its advantages in some logically, it has advantages in terms of separation of cursors, but I prefer this. So we will extend base entity. That's basically the change I need to make. And I need to import it from TypeORM. And now this is an active record model. Now, the columns. First of all, we don't have an age column, but we do have a first and last name plus an ID. We decorate this with primary generated column. That's great. Let's see what other columns we have from the ER diagram. That's why the ER diagram is helpful at this stage. If you didn't plan your architecture, you would have to invent it. And also think about syntax, also think about errors. It gets much more complex than drawing a diagram with rectangles. So I have the email. I'll use the same syntax. Email, that is also a string. Password, let me copy that. Password, that is also a string that will be hashed. We have to handle that in the model, of course. First, last name, and currency. That will also be a string, an ISO string of a 3-letter ISO string, basically. Yeah. All right. That's a good start. Now we have an entity with all of our columns. The next step is to think about, first of all, validation, and after that, the password hashing methods of user. Now, validation, if I look the recommendations for validation in TypeORM, they recommend using the class-validator library, which is pretty cool as it also uses decorators. I'll install it and show you how it works right here. I can also remove the TypeORM boilerplate because we don't need it anymore. I copied whatever I needed from that. All right. I installed the class validator. And if I Google that, there we go. It allows the use of decorators to validate any class. Then you have to use these validate methods to actually perform the check. What we'll do is we'll decorate the class with validation and then add hooks, or in TypeORM they call it listeners and subscribers, for before insert, before update, to automatically validate the whole input at this point. All right. Yeah, this is how we're going to handle it. I can actually copy from the documentation some basics. Yeah, let's leave is int length. I will need an email validation. I don't need the is date, min, or max, I think. Let me change the double quotes again. All right. So no need to validate the primary generated column. It's never edited by the user. Here, I'll do the validation after column. Is email, what I need. And here we have two basically options, if I remember correctly. Let me open the documentation again. I just want to add a validation message in case it is invalid. And first we have the options for a certain validator, and then an object of other properties, one of which is message. In this case, I don't want to set any custom options for isEmail, although I'll check them in a bit what they are actually. But I want a message, which will be email is invalid. Now, I don't want to hard code these messages and have them be inconsistent. So I will make a helper to generate them, at least for invalid messages, the broad general messages that some input is invalid. I'll call it the file validation messages. Get is invalid message. That will be a function with a field label input that will be a string, and it will return a string. That's an arrow function, of course. It doesn't need a body. It will just return a template literal saying field label is invalid. All right, very good. I will, without the dot, this is an individual label. So now I can import that from helpers. How was it called? Get is invalid? No. Oh, I need to export it. Here it is. All right, now I can use it to generate this message. Get is invalid message email. All right, besides that, let me check what the settings are for is email, although I'm sure I don't. Is email options. That's not documented here. This class validator uses validator.js, which has an is email. And let me see. Options, here it is. So this is the actual options object. I don't really want to change these. When I read what they are not very useful. I need just basic validation if the format of the string is a valid email. And that will do it and return an appropriate message. Next up, we have password. So here we have a couple of things. a regex validation would be best. In that case, you would want something like a test for strength involving length was a requirement for symbols. You have a couple of options. You can write your own regular expression, of course, if you're in masochistic mood, or you can find some regular expressions online, but always check if they are correct and what they do. So here we have in Stack Overflow an article where we have a bunch of password regexes, minimum of 8 characters, at least 1 letter and 1 number. I think this is sufficient in my opinion. I don't want to be too draconic in terms of security. Now let's go to regex 101 and check. Let me remove that. Okay. Any character, 0 limited times. Okay. Yeah, it matches if we have less than 8 characters. And all right, it would also require, let me see, it was supposed to require a letter and and a digit. Okay, yes. So it would do exactly as it specifies. You can use this kind of regex analyzer if you don't understand regexes perfectly like a normal human. Or you can also experiment with generative AI. Sometimes they can explain regular expressions quite well. Might not be that reliable though. Either way, this regular expression will work great. So let's see how to add it with the class-validator. Matches. Okay. Check if string matches the pattern. That's exactly what we need. All right. So the pattern will be my regex right here. All right. And then we have the options again, message. Now here I might specify a more thorough validation message. Not just that. I might not need this isInt, isLength from class-validator. So let's see. I'll import them if needed. Here, password is invalid is not exactly that specific. I don't want to use this generic message for this specific field because I want to tell the user what are the requirements. So I would say password is invalid. Oh, I can actually use that. I also have an additional, let me show you what I have planned. Get is invalid message for password. This will say password is invalid. And then I can tell the user that use a password with at least 8 symbols, including letters and digits. So that should be specific enough, I think. All right. First name. I cannot stress enough that handling validation in the model is, in my opinion, the best way to do it. Keep in mind, at this stage, we're defining the model in an ORM that will build the database entities. So this is the sort of baseline of our application. It's core of the server. You have other validation layers on top. You have an option to build validation in the controllers. I don't like that option because here you have the schema. It's a great place to do it. The models are usually the best place for validation on the server side because you define the schema there with the types and the fields. The controllers are usually the place where you move data, orchestrate model operations, not do validation. And of course, you have client-side validation, which you can never rely on because it can be, users can go around that. It's client-side. JavaScript can be modified on the client. So you need server-side validation as an extra layer of validation. You can rely only on server-side validation and avoid client-side validation completely, meaning you have to show validation messages to your user and validate your forms with the server. The upside to having client-side validation as well is that your users will get validation messages faster, as you don't need to wait for a server response. Plus, you will use less server resources. Essentially, you will not make a request until you're sure the validation is correct on the client. So this validation on the server should ideally be just a second layer of protection against invalid data going to your database. Either way, I got sidetracked talking about validation. Here we have first and last name. I will do length checks for these. This should be enough. Length, maybe, wait, can I use min max? Let me see. Class validator. So length, checking the string's length falls within min or max range. Okay, so length is great. 2 numbers here. 2, I think, should be correct. Let me think. In some Asian languages, not sure if there are names with one symbol. Okay, you can have one symbol names. What is now the length of a first name? I think 50 characters is fine. I was looking for some reasonable data, but there isn't any. So one symbol up to 50 should be fine for a name field. Absolutely fine for a first name field. And I'll do the same for last name. Besides that, let me see. Length, yeah. Oh, it's worth mentioning. With class validator, everything that you don't denote as is optional is required. That is already validated. So that's great. Currency. Currency needs to have a default here in the model, not in terms of validation. So here we have the default option, and that would be, I think, USD. Yeah. Let me find currency, string ISO codes. ISO 4217 is the currency ISO standard, and United States dollar will be a 3-digit string. 3 letters string. Okay, I'll use the letter code, not the number. So the default will be United States dollar. With that in mind, let's validate it in length. It needs to be exactly 3 digits. Actually, can I provide only one? Will that work? I don't think so. I don't think there's an overvote on that. Besides that, this will be optional because we have a default. It's pointless to validate through an enum with all currency strings. Pointless is a strong word. It's not pointless. It would make it would make the field higher quality, but I'm considering that. Should I make an enum with all currency codes and validate it? No, I won't do that for now. For that specific reason, I think client-side validation will be enough. Even if you exploit the application and change the currency code to something invalid, what you will ruin is the symbol showing next to your numbers. And I don't know why you would do that. No point. Still, it might be a good practice to check the enumerable values. To check if the value falls within an enum of all of the allowed values for this field. I would consider that in the future. For now, this validation is sufficient. All right, so at this point, we have all of the fields of the user model and we have validated them. What I'll do next is hash the password. But before that, let's just check check, test the model basically. I copied this index from the boilerplate code that was generated by TypeORM. And here's what it does. It's currently in my index file. Let me change the double quotes. It imports the user models. It initializes the data source, creates a user, saves it, and retrieves it. Let's do the same thing, but better. I will structure my application like this. I have a separate app.ts file that will contain an application class. That application class will have a static main asynchronous method that will be the application entry point. This file will export the application class by default. Pretty straightforward architecture. What my index file will do as the actual entry point in the NodeJS app, this is the running file, is execute the main function, which is my actual application entry point in my architecture. So I import application from app and run the main function. The rest of this logic will go into my app.ts file. And it will be much more concise because I'll use async await at the very least. I'll leave these imports because I need them. So app data source initialize is what initializes the database connection. I need to do that. It's a promise, so I will await it. After the database connection is successfully initialized. Let me remove the console logs for clarity. All right, better. We can create a new user and set up some data for it, just to test. The rest I can delete because it uses the repository pattern, not the active record pattern. So we create a new user, set its email to something. I will just do that. Just some basic password. I will input the other fields as well. I will not set currency. I want it to be the default one. And I don't think we have another field. First name, last name, password, and email. That's it. ID and currency will be auto-generated. And now we save. That should create a user. Our console log, user created successfully. Only save is async, so we have to await it. All right, let's see if the models are running correctly without errors and everything is functioning. We have an error. Let me see what kind of an error. Database BW does not exist. That is absolutely correct. Let me open the Beaver and create the BW database. So create new database, BW. That's it. Yes, close for now. Let's run again. We might have another syntax error, but it doesn't seem so. We get the user created successfully message. And if I open the Beaver again, I shouldn't have closed it. I can check if my BW database, let me refresh right here. My public schema users, and I can open the data. Close all the tabs, and I have my new user, which is great. This pretty much manually tests the model end to end. Now, another thing we can test is validation, which is not working. Of course, it will not work. The password is invalid. It doesn't work. Let me stop that because I just created 3 identical users. Okay, delete them from here. That reminds me, I need this to be unique. So I'll import that from TypeORM, actually. Expected arguments. What are the expected arguments? Let me check. Unique indexes. Yeah. We have... What does the unique decorator do in that case? Yeah, unique constraint. You must specify the entity field names. Okay, I need to apply this to the actual entity and specify the entity field names that are unique. Okay, let me move that. Definitely need to do that because email must be a unique entity. Here we have an array. Let me see, password, first name, last name. Yeah, all of the others are okay. So email needs to be unique. That's important. Now, we currently don't have validation because this validation works only if we validate manually with a function here from class-validator that is demonstrated here, validate or reject, or validate. The difference between these is this one throws an error, which we will use probably. So let's handle that. We need to run this function on update and insertion. Let's do it right now. Here we have the subscribers and listeners. We can do before insert on a certain method. This will run it before inserting anything to the database. We have before insert validate. I'll call the method validate. I'll import before insert from TypeORM. This function, yeah, is basically, I'll leave it like this, not make it private. There's no point. But what it will do, I want it to also do before update because we need the same validation at that point. All right. And it will execute this class validator function, validate or reject. All right, this returns a promise, which is great. In that case, I can make it an async method. I will import it right here from class validator. And what it will do, let me just consider that. It will await, validate or reject, post. Not post, here we're talking about this because we're updating the current object. So this will validate the current object. This throws an error in case any validation fails, which is exactly what I want. That will throw an error on safe, basically, if I update or insert. All right, so let's test that. I'll have an invalid email and I already have an invalid password. So let's start, run def. Okay, unhandled exception because here I haven't handled this at all. Catching an error and I'll console log that error. Should be an object. Here we go. So I get two objects, validation errors. The first one is that email is invalid, and the second one is password is invalid. Everything as expected. If I correct this, how should I correct this? Like this, I believe. We get another issue. Query failed error. Duplicate key violates unique constraint. Now, this needs a more user-friendly error message. So let me check. Can I do that? The unique decorator reference. Yeah. Doesn't seem like it at first glance. Let me check the IntelliSense if it will suggest anything. Unique options. We have something. Let me check. So this, let's look for the references. We don't have anything here. These unique options are not really documented, as it seems. Unique options indicates, okay, good, deferrable. Okay, so there isn't an option for a message, at least in the decorator. I'll leave that like this for now. In any case, that can be handled in a different way, of course. Yeah. Yeah, this can be remapped to a more consistent error message. I'll think about this later, at a later stage. The important thing is the validation is in place. And we have user-friendly error messages for all of these, except first name, last name. Here we also have length, so there should be, there should be a message, of course. Get is invalid message, first name, and I will do the same user-friendly message for last name. Yeah. This. Yeah, sure, why not? I will add validation even to this if the length of currency is outside of the 3-character limit. It's a little bit overkill, but still might be helpful at some point. Let me just zoom out because the error messages are getting longer. All right, I'm happy at this point. The last step, we have validation. The last step is to hash the password when we create the user object. And to do that, I'll use bcrypt. Here it is. We have types, which is good. I'll just install it. Let me see. Is that the actual library? Yes, I think so. Bcrypt. This uses the Boolfish algorithm to hash with south. I will also install bcrypt as a dependency and types bcrypt as a def dependency. All right. So I'll import not in TypeScript in the user model. I'll import everything as bcrypt from bcrypt. Interesting. Why? Wait, did I install the wrong? No, I don't think so. I think this is the correct. Yeah, they have their README only in GitHub right now. The package doesn't show the README. Yeah, okay. That's fine. Okay, the default out rounds at 10, that's fine. We have gens out and hash functions. The other one is compare. This is everything we need. Here's what we need to do. Before insert and before update, we should validate and hash password. I could make this the same method, but I don't want that because separation of concerns. So I would say hash password before insert and before update. What this will do is generate salt. All right. This will be the saved and stored in the salt in the salt variable. It's a string. And it will set this password to bcrypt cache. And we have to provide the data or salt. So the data will be this password. The salt will be salt. Lastly, this will work on insert because this password will be the freshly inserted non-hashed password by the user. On update, we have to check if this password has been changed. Sadly, currently there's no property, it seems, in TypeORM to check if a property was changed during that event before update. That's pops up decorator or whatever. So there is the after vote function. TypeORM will call this every time the entity is loaded. So loading means loading the actual data to an object, which is the perfect time to cache the current password. I would call it cache password. And we'll store this cached password, which will be this password. And I need to define this. It will just be a string. right here. I'm missing some semicolons, I see. No, not decorators. Not here, of course. At the properties of the class, which I will add because I like them. Cache password afterward needs to be imported. I will collapse these because they've become too long and hard to read. All right, that's better. And where was I? Cache password. This cache password is equal to this password. So when we change and when we hash the password, we can check before we do that if this cached equals this password. This essentially checks if password was left unchanged by this update, or by this update. And in that case, I would just stop the function and not salt it, because not hash it, because this would hash a hashed password. Essentially, change the user's password if something else was changed. A user might change his first name without changing his password, and in that case, the application would change his password and his account would be inaccessible. All right, so this should work now. The only other thing I want to add is an async compare password method, which will accept an input password string, and it will return bcrypt compare, this input password, and this password. So this function will basically return, accepts strings, returns a promise boolean. It will return true or false depending on the validity of this password. So I would say is password valid is better as wording. I prefer this boolean naming scheme because it's more self-explanatory about what the function does exactly. Here I'll add comments that this property stores a cached password basically to compare, to check if the password was changed during an update. And I can copy this to 2 rows basically. Yeah. Good enough. Because it is somewhat unusual, I explain it. Why do we cache the password? In order to perform this check. Pretty self-explanatory, but still, a comment is helpful in this case, in my opinion. Now, what do I want to do? I want to save a user and check his password. To do that, let's change the email and create that user. And it was created successfully. Let's refresh the beaver right now. The password is hashed right here. I can remove the first row with the unhashed password. And now the next step is we can check if it's correct. Let's retrieve the user. User find one by ID was the ID 6. So this will retrieve the user. And now I can just perform is password valid. That variable will be equal to user is password valid. Oh no, we have to await find one, so that here user is password valid. That's also asynchronous, and we can input the password, which, if I remember correctly, was like this. I should have remembered it, but now we can check. All right. And console log the result. And the password is valid. If I change that to an invalid password, it returns false. So everything on the user model is working as you would expect. Now we have to define the other models. The user model is actually the most complicated because of these methods. Next up, we have transactions, categories, budgets. I would probably start with transactions. I'll just copy the user model to start from somewhere, name it transaction, and I'll remove TypeScript, bcrypt. All right. Now change the class name to transaction. It will still extend base entity. I will remove comment for now, the unique constraint. So the transaction will have an ID, an amount. That's a number, a date. That's a date. All right. What else do it have? Does it have budget category ID or relationship? But we can define that after the other entity is completed. All right. I'll remove these methods that we have for users. Do we have unique columns, date, amount, ID? No. So I'll remove the unique constraint as well. All right. So we need to validate. Amount is not integer. Let's see. How should we validate? I need the class validator documentation again. Let me open that. Is decimal? Yeah. I want to check if it's decimal. What options do we have? Force decimal, decimal digits. Decimal digits. Should I enforce that? No. A check if it's decimal is fine. All right. And date will be is date. Now I'll import that. I'll remove length and is optional. Validate or reject. Oh, I accidentally removed something that I need. I need this validate function in all of my models, basically. It's a little bit bad that I'm repeating this. I could have created a base model myself and extended it, but I'll leave it like this for now. I'll consider creating a base model and extending it. Now, here I will add a message. Get is invalid message in case it's not decimal for amount. And here for is date, I want to see the options because there are a lot of details around date. There doesn't seem to be a lot of explanation here, so I will go to the validator.js documentation to check if there are more. Yeah, okay. Check if the string is a valid date. Now, all right, this can have a lot of options, but the defaults are pretty good. We have the delimiter set to these two, which is great. Yeah, the defaults are good in that case. So I only need to add a message in case it's not a valid date. Yes. Did I do something wrong here? Let me see. Let me just check if, yeah. All right. Get is invalid message is the first parameter here in that case. Lastly, yeah, we don't have more fields. So in that case, this model is ready. I can remove the unused methods here and decorators. All right, let's go forward with the next entity, which is categories. Actually, I'll leave categories for last because it's more complex. It has an enum. I'll go with budget first. Copy transaction. All right. Budget has an ID and month. Pretty simple. I will set this to a date. It will still be a date. Even though it's called a month, it will be an incomplete date. And I can remove this. Great. So that's also complete. Let me rename it budget. I need to add these here, import them and add them in the data source. So I'll do that right now as I'm writing them. No, not this transaction, the transaction model. Okay. And And what is the other one? It's budget. Okay. Added the other model as well. We have budget. Next up is category budget, right? Exactly right. Yeah. Okay. Copy that. And that is quite simple as well. I'll first add it to the data source right here, so that I don't forget later. I'll get an error otherwise. And the counts ID, we don't have a month, we have an amount number, and I need is decimal check. All right, with its default options again. We'll add the foreign keys last, and now what left is the categories. All right, let me not plural, singular, sorry, category. Add it to the data source again as another entity. All right, category has an ID, a title. Wait, amount number. I do have an accumulated amount. So I change this amount to ACC amount. Yeah, I will set it to this. This is meant to be an internal name because this will be either the leftover amount or the actual, the leftover amount if this is a debt, or the saved accumulated amount if this is a savings budget, a savings category. So this is kind of an internal message. Still, this value should not be modified by the user. So this message will not be visible to the user either way. Accumulated amount is correct. In case an exception, an undetermined, unhandled exception occurs, this will pop up and it will be easy to trace the error based on that. Still, is decimal is the right validation here. Let's add a title now as another column. It will be a string. Sorry, that's not correct. I want length here. I will basically check if it's between 1 and 50. And if it isn't, just send invalid message that the title is incorrect. And what else? A foreign key and a type, that is an enum. Let's add the type right here. And let's check how to implement it. First, I want to check if we have an enum here. We do. So we have a column type enum. Here we go. We define an enum in TypeScript. I can do that here. Actually, this enum, this is category type, and it will be either income. I could do this. Let me see. We have income expenses, income expense, savings, and debt. I'll just specify them full length. It's the safest route. It's not that much data to store. That's what I was considering. You could go with numbers also. Numbers might be a good option. Yeah, numbers should work fine. And this is a good place to export category type. This is the category model, so that's fine. All right, so how do we define the column type? Here we have a user row. So the type of the column Let me find it. Will be that. And here in the column definition, we have type enum as string. Interesting. And the enum, which will be category type. Do I have to, sorry, I have a typo. Do I have to have a default? Probably not. I don't want a default here. It's a required column in any case. Now, the next step is to check if we can validate enums with class-validator. And we can. Is enum right here. Entity object, and the enum is category type. And then we have a message. Let me import is enum. A message, hopefully. Okay. And I'll add the invalid message about type. Now, the validation, the user-friendly validation messages for these columns, which will not be modified by the user, are not that necessary, but they are a nice touch. And then if an unhandled, unpredicted exception occurs, you might get a nice user-readable error message instead of some gibberish. So your users would appreciate that. You might appreciate that as well. If you get a user-friendly message, you'll be able to trace it immediately to the wrong field, to the wrong input you have. All right, so we have validation here on all fields. We have all of our entities. Now we can define the relationships between them. Starting with the user relationship, I want to start right here in categories, where each category belongs to a user. We have one user to many categories, a one-to-many relationship. So let's look for that in TypeORM. To many. There we go. One to many and many to one. Well, basically, we'll start with many to one as we are at the categories table. And the example is with a user actually, which is cool. It will be the last column. I need to import many to one. I need to import user as well. All right. Well, this is type is unnecessary. It's an unused attribute just for readability. The user is a user. User will be mapped to user categories. This is a new property we have to build in at the user side now. Let's go there, where we'll have many to one. Let me see. One to many. Here we go. Here at user as last property. One to many, import it again. Let me find it now. All right. And the type is category, which should be imported now. All right, it is. Category, and we have category user. And the property here is categories, which is a category array. So now here in category, the error should go. And we have a relationship defined. Great. No errors in the console, which is a good sign. First relationship is ready. Now let's do the next one, which will be the, let me see. We have what is related to categories. The category budget. All right. The category budget is related to both budgets and categories. So the relation to categories is one to many. One category can have many category budgets again. So let's just copy many to one from the category in category budget to define that. Many to one, I have to import again right here. And I have to import categories. All right. I could have avoided importing it. If I start writing it here, it will import it. All right, so category, here we have category. There we will have budget categories. All right. No, category budgets, an array in the remote category. And here we have category of type category. I repeat that a lot, but this is how it is with types. Might be annoying. I'm sorry. And here we have one-to-many. Let's copy that from users because it's the same syntaxes. One-to-many. Let's import it. All right. One-to-many to a category budget. All right. Import that as well. Did it recommend? Yeah. And here we have category budget. This is basically where the remote relationship lies, if you haven't figured that out already. And here we need to name that category budgets, which is an array. And this relationship is done. We basically define the relationships for both ends. On one end, it's one-to-many. On the other end, it's of course many-to-one. Now, the next relationship we have is budget ID, which is again one-to-many. One budget to many category budgets. Let's start from the category budget side, many-to-one. I will import budget, and here we have. There we go. So basically, here we have a budget property, and that is done. Let's go to the budget side now and copy the one-to-many property. Many, we have to import that. And here we have many category budgets, part of a budget. And this is what? Category budget. This is correct. All right. Let me just check here. All right. Yes, that is absolutely correct. So these relationships are done as well. And do we have anything else? Transactions. So the last thing left is transactions. One transaction is related to a budget category. Budget categories can have many transactions. Again, one-to-many. Let me see. Yeah, many-to-one in transactions. Let's import it again. Quite repetitive. So a transaction is related to category budget. And here we have category budget. Transactions will be called the array there. Here we'll call it category budget, and it will be of the type. And now we just need to go here and define the one-to-many relationship with transactions. All right, first import it, import one-to-many, the decorator, and then we will specify transaction. Transaction category budget. Didn't I call it like that? Let me see. I think so. Category budget, yeah. Doesn't seem to catch that. Oh, it imported the wrong transaction. That's why. That's how TypeScript is helpful. It helps with these annoying, stupid errors which you don't want to make because they waste so much time. But now that that's done, I can have transactions here, which is an array of transactions. And you can see how this will be helpful. When I retrieve a category budget, I'll get, if I want them, my transactions from it. All right, one last item. All of these should be populated and correct. I can test all of them.
but that the actual testing will happen separately. I will need a thorough testing strategy for these models, so I will not handle this in that video. This is how the basic transaction models will work. In the next video, we will test the models and work on building the actual controllers or GraphQL capabilities, or the GraphQL server to retrieve the data and implement resolvers, basically. But yeah, we'll work on the controller layer and testing the models.
With this, I'll wrap today's video. If you enjoy the content, don't forget to subscribe to get notified when another video is released. Take care.